So students, we are going to start another topic, design principles of welded joints. This is a part of series of design and performance of welded structures. Six points that we need to consider very effective. Number one is the determination of loading conditions. Second is major design factor. The third is the weldment design. The fourth is the weld joint design. The fifth is the size and amount of weld which is used. And the sixth is the welding procedure. So we're going to basically start all of them step by step, and we will start with the conditions. So it is quite important to have the general understanding and idea of the loading conditions involving the forces which are involved, whether they are static or dynamic, whether they are shear or normal forces, etc. So these are some of the important forces that we need to keep into consideration. We move to next, and the second is the major design factors which are involved, which is the strength and stiffness, the safety factor, the appearance of the weld, symmetrical sections that resist bending, and welding at the end of the beams for rigidity with the welded stiffeners. These stiffeners are used basically to make the structure more rigid. Then we've got tubular sections, whether the welding is going to be piping, seamless, non-seamless, etc. Which standard roll sections are to be used, and what would be the impact on the economy, accessibility and maintenance, and standard commercially available components specified by index units, etc. So some of the factors that we need to consider are given here as 10 points. For example, if we take a look at strength matching, number one, we need to consider whether what should be the joint efficiency. Here is an example. If you can see here, you can see that we've got a matched, overmatched, even matched and undermatched system, and each of these have their own consideration, whether we should use 100% joint efficiency, etc. We move to the third, and that is more or less related to the design of weldments, and there are some general points that we need to see for the design. This is followed by parts preparation, how are we going to make the part, and the third is how forming is going to be, what are the forming techniques that we are going to perform. So let's start with general points for that. And general points of effective design basically starts with the ease of handling of materials. This is followed by what are the cost saving strategies that we are going to employ, and then what are the realistic tolerances which we are going to give for our structure, and what are the, how minimum can I basically reduce the number of pieces. These general points part preparation, and for the preparation of the parts, it is important to select an appropriate method. An appropriate method could be for thermal cutting, shearing, etc. So how are we going to prepare a part is very important, and then whether we need to do back weld preparation, should it be under carbon or guffing, etc. These are some important parameters that we need to consider for parts preparation. This is followed by, and forming starts with basically number one is that what would be the base material composition. Next would be then what is the part thickness, then the overall dimensions are required to be considered, production volume, tolerance, and this is followed by the cost. So everything revolves around the cost as well, and it is important in this current era to go for cost savings. But it is important to note that cold forming reduces the ductility of material but increases the yield strength of the material, whereas generally the relevant standard provides maximum cold forming allowance. This is given in codes and standards by the AWS API, etc. So we're going to move up to our fourth joint design, and this starts with whether should it is basically based on the loading requirements for our joint, and what is the design layout, and then how much that substantially affect the cost, and this is followed by what are the general rules for the weld joint design is basically based on the guidelines and the general rules which are established in the industry. The second last is the size and the amount of weld which are going to use, and sometimes what we do is over designing, and over designing is uncommon, and it basically reduces the efficiency, increases the production time and cost. So the control of weld size basically begins with the design itself, and all the assembly, forming, etc., all those operations are required to be weld joint design is also accompanied with sub-assemblies, and basically these sub-assemblies are required to be visualized, and some of the advantages of sub-assemblies are basically that we can work together on sub-assemblies together. So if we put one production line and then we put another production line, so what we can do is we can do parallel production line to increase the product processing time, and these assemblies can perhaps be optimized through various further points number 2, 3 and 4. Sub-assemblies is further followed by other additional parameters, for example machining, post-weld heat treatment, PWHT, and then what are the tests that we are going to perform, the leak test, the inspection, radiography inspection, magnetic particle testing, etc. What are the cost involved? So these are some of the points which are related to this. And the last is the procedure of whether the welding design has an effective procedure or not, what kind of position we are going to use, what are the joint design, whether it's overhead welding or 1G, 2G, 3G, etc. What kind of supports we are going to be for the welds, and what kind of electrode used, what are the reinforcement which are going to be used, whether it is necessary or unnecessary. So these are some different guidelines which are basically given for welding procedures. Reading material available in the supplementary slide are basically some of the basic guidelines for the control and size of the amount of weld. So you can go through each of these as a self-learning. So thank you for listening to the slides.